Texas Instrument built it, sold it, but they only sold it to whoever made these movements. If I'm a little bit lucky, someone out there will have a data sheet and I'll be able to find it. But continuing on, I got another cap right here going to pin 3. That's this guy. And there's a connection underneath it to that line. I really like to remove this little cardlet from this, but it looks like it's stuck on with some double stick tape, and I'm really afraid of breaking it, in which case it'd be game over. If this gets to be too big of a pain in the butt, I can always just unsolder this chip and be able to see a little bit more in here. Oh, that's interesting. It looks like this third cap goes to that pin, flips underneath, goes around pin 4, goes to another cap, and then that cap goes into pin 4. I screwed up. So cap, this is the brown top, these 3 are red tops. Goes into pin 4. There's also a resistor on it which goes to 12 volts. I shouldn't draw that there. .12-volt connection right there. 5, 6, 7. Pin 7. Uh-oh. Yep, 7. Off of pin 7, there's a resistor that goes to pin 8. Uh, 8, 7, pin 6 has a resistor that goes to ground. And I'm running out of space. So 4 we've got covered. It goes to this cap, and it looks like nothing else. Pin 5 is hooks directly to the meter movement, from what I can see. It's really hard to see if this wire here just goes there, or if it's also bridging to this trace. I'm thinking that just goes there, so that's pin 5. And then the other side of that goes to power. Pin 6 we covered, 7 we covered, and 8 we covered. So here's the entire circuit. So this here is some sort of high pass, low pass filter, because you got the resistor cap into pin 2, which must be the input of the circuit. pin 1 is ground, pin 7 is power, 6 and 8 must set some sort of tuning on it. Without finding out what this is, I don't really know. 5 is the output to drive the meter movement, and then 3 and 4 must be some sort of, another stage of filtering. Again, you got caps to ground, series caps, and caps to power. So I'm betting that is another analog filter pole. This could potentially just be an op amp, and then they're doing analog or active analog filtering. So this part here looks like this input filter there. So what is that? That is a first or second order filter, then cap. I'm going to do some research off camera and see what I can dig up on what that chip is. If it's truly just a single-ended op amp, and this is just a big analog filter to take out, high frequency, low frequency components, this could make sense, because as the engine runs faster, the pulses get closer together, which would deflect the needle more. Basically, the engine is PWMing the movement, sort of, not really. The pulses, it's sort of inverse PWM. PWM, usually your time base is consistent and you grow and shrink the width of the pulses, where in the case of the ignition system of a car, the pulses stay the same width, because it's just the closing and they stay more or less the same width, because they just open and close, and then your whole entire time base, as the RPMs go up, the time between pulses shorten. Old mechanical points with condensers, the width of the pulse and the time base sort of more or less stayed about the same, but the condenser would stretch the pulses out a little bit. This car has electronic ignition in it. It's still distributor based, but it has an electronic pickup. And I know the dwell is fixed on it. The dwell is how long it stays closed. So with a fixed dwell, that pulse should always be the same width, and then the time base just moves around. So I think I'm going to wrap it up for this video with that. And I'm going to go do some searching online and see if I can find out what a TI M7714 MIC2 IC is. I just got to make darn sure I put my cap back in before I go. But again, that cap is just a filter, or a bulk power type filter. It goes between ground and 12 volts. I should check that little guy right there. It'd be really interesting if that was just some sort of little polyfuse type thing, and in the dinking around, whatever killed the ignition also blew that out. No, it's basically a short. 150 ohms. This thing probably doesn't draw much current, so that's probably right. Since I'm in here poking. So this first resistor, 150 ohms. The first pole of this input filter, ooh, big a resistor is this? Or is this the problem? Oh, 50K. That's not totally unexpected. 46.6K. This next pole of the filter, I may not get good readings because I got caps on either side of it. 32K. I'll go with it for right now. Everything else has a semiconductor around it. What I mean by semiconductor, like if I try, this one's easy to measure because that's open. This one's relatively safe because you have these two caps on either side of it. So when I hook the meter across it, it's going to charge these two caps, and once they're charged, I should get a decent reading, minus whatever equivalent series resistance we have, or parasitic resistance we have inside the capacitors, the leakage. Whereas with this resistor, I have pin on the IC to another pin on the IC, so depending what this IC does, I could get all sorts of wonky readings. So, okay, so the easy bits are done now. This resistor's not open, so we know this thing's getting power. This path's good, this path's good. So we're down to figuring out cap colors, and which is brown, black, yellow, black, red, and the other one is red. That might be a red, orange, black, red. These color-coded caps, microhenries, were a little weird to decode. I do not claim to be an expert on them. 2,000 picofarads. So brown, black, yellow, but it's a 5-banded part. My little Radio Shack cheat sheet doesn't go up to a 5-band, so I don't know if that value is correct or not. So again, Googles are your friend. I'm just going to go punch this stuff into Google and see what I come up with. So that is it for now. I'll do some more on this once I find some more information. Laters.